Okay, so today, Common Core Standard. What we want to talk about is the law of sines with the ambiguous case. All right. So right off the bat, I think, Lane saw it first, and that was this darn inappropriate word, ASS, right? And say, wait a minute, Mr. Davies, what kind of class is this? Well, if we go back to geometry, and in our geometry books, they never, ever publish it as ASS. They always publish it as side angle. They do that on purpose because, obviously, ASS could be a bad word. Not necessarily, though, because we could be talking about a donkey, right? So in geometry, we had side, angle, side, remember? In geometry, we had side. We had angle, side, angle. But what we did is we said you cannot have a side angle. We can't. And then you said, well, same, or we can't have an angle, side. Now, a lot of kids thought we couldn't have an angle, side because it was a bad word. That's not true. There's a reason we don't use the angle, side. And we're going to learn that today. You can't learn why it doesn't work in geometry. You have to learn it in trig, okay? So in geometry, if it was a angle, side, you would know an angle. Let's say this is 37 degrees. You'd know a side, let's say this is 10. You'd know another side, let's say this is 6. Okay, that would be a angle, side, or a side angle, right? And in geometry, I told you guys that you cannot say two triangles are congruent by this rule because it doesn't work. Why doesn't it work? Well, let's check it out, okay? It's called the ambiguous case for a reason. So what I want to do is construct it, okay? First of all, let's go ahead and try and draw a triangle. So you guys have your protractor, your ruler. So what I want you to do is put a dot right here and call it A. Okay, put it all the way over as far as you can. Put A right there. Put a dot, Hayden, put a dot right there. Call it A, okay? Because we want to draw and put it down a ways. Put it down near the bottom, okay? Put it down near the bottom, okay? Because we're going to draw a triangle in here, okay? Take your ruler and we're going to draw the terminal side and just draw it good and long. We don't know how long it is yet, but we're going to find out how long. So go ahead and just draw. Get your point A, draw a line across, okay? Because we're going to construct this triangle, okay? Just nice and straight and long, okay? We do not know how long this line is, so just draw it good and long, okay? Now your protractor. I need an angle A to be 30 degrees. So I'm going to take my protractor and I put the little dash on my angle A on my dot and put 0 right there, okay? So use my protractor, put the A there, put the 0 here, and then I need a 30-degree angle. So 10, 20, 30. And put a little mark there, because I want to draw my angle, okay? So at 10, 20, 30, put a little mark right there, okay? And then that'll help me draw my 30-degree angle, okay? So now, let's draw side B. If this is angle B, let's let this be side B, and side B is 8, okay? So I'm going to use my ruler. I'm going to draw it 8 centimeters. So I'm going to go ahead and just go 8. Put it right there. Put it right there. And so I drew that 8, that's side B, okay? Made it exactly 8 centimeters. I want to draw this to scale, okay? Go ahead. I've got 30 degrees here. And I drew that to be 8 centimeters. Okay? See what I got? How am I doing? Okay? Now I need to draw also side A, which is 9. Of course, if this is angle A, then side A's got to be over here, right? So now I need to make my ruler fit. I need this to be exactly, Grace, turn around. I need this to be exactly 9, don't I? So I'm going to use my ruler, and I need to just fit it in to where it would touch at 9. Okay, so I need to fit it in. So it's just, okay, there's 9. I'm just going to touch the other side right there, okay? So I'm trying to fit my ruler so that it'll be exactly 9. I draw in my side. This is going to be side A, which is going to be 9, okay? Now, if this is side B, then this has to be angle B, right? And if this is AB, this has to be angle C. That makes sense. And then this would have to be side C. Okay. Now, I want to solve this triangle. So to solve the triangle, I'm going to look at it, and I do have a pair of opposites. Got my opposites there and there, right? So I'm going to use my law of sines, okay? So I've got my opposite. Seems to me as if I can find angle B, right? Opposite there, right? And yesterday I always said the easiest way to do it is to write down what you don't know first, okay? I don't know angle B, so let's write sine of B over its opposite side, over 8, equals my other opposite, sine of 30 over 9, okay? So I just use the law of sines. All I'm doing, okay? Doesn't look too ambiguous to me yet, okay? So I'm going to go ahead and solve for angle B, so I'll multiply the 8 up. So I have sine of B equals 8 times the sine of 30 over 9. And I'm going to use my calculator, right? Make sure you're in degree mode. Okay, put a little side note here. I did this second period and I got all the answers wrong because I wasn't in degree mode. I got an answer, I go, what? That doesn't make any sense. So I checked my mode and I was wrong. And now I'm in the right mode. Check your mode, make sure you're in degree mode, because if you're in radian mode, you're going to be in trouble. Okay, so I'm just going to type this in. I'm just going to go, okay, 8 times the sine of 30, close the parentheses, close your parentheses, divided by 9. I get a decimal, right? I get a decimal. Well, that's not my angle. 0.4 can't be my angle. But when I want to find the angle, I always push the inverse button, right? Always push the second button. Okay, so I really need to do a sine inverse of this 0.4. So I do that sine inverse, right, of my 0.444444, and I get an answer. Okay, 26.4. Now that answer makes sense. That could be. So angle B is going to be about a 26.4 degrees. Okay, got it. There's angle B. Easy. Angle C, that's easy to find angle C because 180 degrees in a triangle, right? So I can find angle C pretty easily. That's just going to be 180 minus my 30 plus my 26.4. Okay, let's do that. 180 minus parentheses 30 plus my 26.4. And I get 123.6 for the third angle. All right? Now, I have all three angles. I'm only missing one side, and that one side's little c, right? So we'll, again, set up the law of sines, because we've got my opposites. Okay? So I'm going to go ahead and set up for little c, and I'll go little c over the sine of 123.6 equals 9 over the sine of 30, right? Equals 9 over the sine of 30, okay? How am I doing? Am I going too fast? Okay, am I all right? Multiply that up, right? So I'll have little c is equal to really 9 times sine of 123.6 over sine of 30, and I'm just going to use my calculator. 9 times the sine 123.6, close the parentheses, always close the parentheses, divided by sine of 30, and I get about 15, 14.99, how about 15, okay, so little c is 15, okay, alright, we solved it. Doesn't seem too ambiguous to me. So what's the big deal about this ambiguous case? Let's take a look at example 2. Maybe something ambiguous is going to happen, alright? Okay, slide up, because so far that doesn't seem like a donkey triangle at all to me. It worked, right? Okay, let's check out number 2, okay? Am I going too fast? Or am I okay? Thumbs up? Thumbs up? Okay. All right, let's take a look at example 2. So example 2, again, let's draw it. So when I draw this, I'm going to make a point way down here, angle A, okay? Make a dot way down here on the bottom. I'm going to draw in my terminal side of my angle. Okay, so I need to make an angle, right? So draw that line segment. I need angle A is 30 degrees again. Use my protractor, okay. And I'll put the little dash right on angle A and I'll zero it out. Again, I'll go 10, 20, 30. I'll put a little mark for my 30-degree angle. Okay. I'm going to draw this side B. Side B is going to be 10 centimeters, so I'm going to take my ruler and draw it 10. Okay, there's little b is 10, okay. There's my 30 degrees. And then I need to draw side A, which is 3 centimeters. So if this is angle A, then side A is over here. This is angle A, then side E. Felicity already sees it, okay? So I'm going to draw my 3. Something's wrong. It doesn't work. 3 is only this long. That's not even a triangle, is it? Weird. Had I not drawn it, I probably would have tried to solve it using the law of sines, and I would have had something like this. I would have had like, oh, I don't know, I would have had like maybe 10 times the sine of 30 divided by 3, right? I mean, I would have done the law of sines, and, you know, I would have gotten an answer, and then I would have gone sine inverse of this answer, and guess what I'd get? So my calculator doesn't even like it, does it? This triangle does not exist. You guys are going to like this triangle. You know why I like this triangle?
You don't have to do any work.
Exactly. We're done. No triangle, right? That is a little ambiguous, isn't it?
True.
Okay. Now the first one we could solve. Second one, there is no triangle. I like that one. We're done, right? Okay, let's turn the page. All right. So let's draw this one. Okay, so put a little angle, a little point A there. Hey, Charlie. Okay. And again, I'm going to draw my terminal side. Okay, I need a 30-degree angle, right? Okay, put my 30-degree, 10, 20, 30, right? I'm going to draw B at 10 again. Okay, so I'm going to draw 10. Okay. Right? 30 degrees. B is 10. And now I need to draw A, which is going to be 6, right? Okay, go ahead and see if you can draw that, okay? Go ahead and draw in the 6, all right? See if it matches up. Okay.
What happens if it's long? You can't. You can't? No, because remember?
This one was. Check it out. This one was longer.
Yeah, no, but
This one was longer. Like longer, which way? Okay. How am I doing? You guys good? You guys, so did you draw it in? Felicity, can I borrow yours, please? Nicely done. Nicely done. Okay. So, did everybody get this picture? Yeah. Anybody get anything different? Everybody get this picture right here?
Yeah.
Okay. All right. Nice. Very good. Nice job, by the way. That's right. But so is this. Watch carefully. Hey, is that 6? Is it going to make a triangle?
It's gonna make a triangle.
Which triangle's right? Am I right or is Felicity right?
You're both right.
We're both right.
Everyone is right.
Kind of ambiguous, isn't it, right? So in this case,
Can you do that with the 9 centimeter triangle?
no, because, great question, because the 9, you'll see it visually, you'd flip beyond it, right? Does that make sense, Lane? Really good question. 10 would work. You would get either an isosceles triangle or you'd get no triangle at all, right? So let's go back to this. So let me go ahead and I'm going to draw in Felicity's because this is right. And this is the way most of you guys drew it, right? Here's my 6. So there's basically 2 triangles. Now what I want to do is highlight both, okay? Let me highlight the one you guys put first, okay? So let's take a look at this triangle here, okay? You guys got that one right?
Yeah.
And then we're going to ignore my triangle for right now. Okay, we're going to ignore mine. So here's angle B. This is 6, angle C, and little c. Okay, so for right now, we're going to ignore my triangle. I'm going to bring it back because there's two possible triangles. There really are. Which one's correct? They both are. We're going to solve for both, all right? So let's go ahead and do angle B of the big triangle first, okay? So angle B, again, law of sines. I've got angle B, its opposite side. I've got the 30, and so I've got my opposites, right? So I'll start off with first sine of B over 10 equals sine of 30 over 6. I'm going to need to use my inverse button. Have to use my inverse button because I'm looking for the angle. Multiply up to 10, right? So if sine of B is equal to 10 sine of 30 divided by 6, right? I'm going to use my calculator. So I'm just going to go quit. I'm going to go, all right, 10 sine 30 divided by 6. And I inverse sine that, right? We've got to do the sine inverse second sine because I have to find the angle of that answer. So angle B is about 56.4. 56.4 degrees, okay? Great. This is not that bad, right? And if I need then angle C, well, I can do that, right? Angle C is just going to be from 180, right? So angle C is going to be just 180 minus my 30 plus my 56.4. All right, let me go ahead and do that on my calculator. Am I going slowly enough?
Yes.
Okay. 180 minus parentheses 30 plus 56.4. So about 93.6, right? Right? And then the last thing to find on this triangle is little c, that side c, right? So again, law of sines. I've got my opposites, right? Got my opposites, so I'll still set up my little c then over the sine of 93.6 equals my 6 over the sine of my 30, right? Opposites, right? I've got opposite c over the sine of that, opposite 6 over the sine of that, right? So if I multiply up the sine of 93, I'll have little c is equal to 6 times the sine of 93.6 over the sine of 30. And I'm just going to use my calculator. Okay, so I'll go 6 times the sine 93.6. Close the parentheses. Always close your parentheses. Divided by sine of 30. Okay, and I get an answer of about 11.97 or about 12. Okay, so little c is about 12. Okay, so that's one triangle. Okay, now we're going to have to solve for both. So let me go ahead and take a look at the triangle I drew. So I drew this triangle, didn't I? I drew this triangle, okay? So now let's take a look at the orange triangle, because the orange triangle is correct. It follows all the directions. I mean, I drew a 30-degree angle. This side's 10, right? And this side is 6, okay? So my triangle's correct also. How am I going to solve for this one? Well, first way to do it is this. Let's go back to geometry. If I look at this inside triangle right here, okay? I'm not solving for this, but let's look at this inside triangle right here, okay? But I know this triangle is a nice isosceles triangle. 6 and 6. Does that make sense? Which means this angle and this angle are equal. Remember that from geometry? Base angles of isosceles triangles are equal. So that means that this angle here is also 56.4. Well, wait a minute. In my triangle, this is no longer angle B. Angle B is here, right? I need to find that angle B. Well, that's actually not too hard. How many degrees is a straight line? So to find angle B on the orange triangle, so let's do the orange triangle, or the small triangle, we can find angle B as 180 minus its other angle B, because these two angles are equal. So to get that angle B, see the 180? So I'm just going to subtract it from a 56.4. Use my calculator, 180 minus 56.4, and I get an answer about 123.6. So this angle B is 123.6. 123.6 degrees, okay? Now, Angle C is certainly different, isn't it? Angle C is a lot skinnier. So the angle C I need to find is this angle C up here. So same thing, 180 degrees, but it should be a different answer, shouldn't it? I mean, it's not as big as that, smaller now. So to find angle C, I'll do the same step. I'll go 180 minus my 30 plus 123.6, and I'll get the other angle C. So I'll use my calculator, 180 minus my 30 and my 123.6, and I can answer 26. So angle C, I got to be 26.4. Right? Squeeze that in there, 26.4 degrees. And then finally, side C, which is no longer this entire side C here, because I'm looking at that triangle, right? So side C is really a much smaller side. That's side C there. And we can set it up the same way. We can use the law of sines. We've got the opposites. I've got my opposites, right? That's 6 now. So let's set it up. I'm going to go the same thing. I'll go little c, run out of room, but I'll slide it in here. Little c over the sine of 26.4 equals 6 over the sine of 30, right? I'm setting up my opposites. Setting up my opposites. So I've got little c over the sine of its angle equals 6 over the sine of 30. And I'm just going to cross multiply. I'll bring this up here and I'll use my calculator. So I'll show it on my calculator. So I'm skipping a step, but you know I'm going to multiply by 6, right? So I'm just going to go 6 times the sine of 26.4, close the parentheses, divided by sine of 30, and I get an answer of about 5.33. Okay, so it is ambiguous, right? Because if all you were given was the original information, you would have no idea whether you are going to have 0 triangles, right? You wouldn't know until you got an arrow. Or whether you'd have 1 triangle, right? But you wouldn't know until you drew the triangle. Or whether you had 2 possible triangles. You wouldn't know that unless you drew it. It is ambiguous, right? So, hence, it deserves its name, doesn't it? Okay. That's all I got.